Hi, it's Lewis from the Gen Z Leadership Project, and I'm here with my third video on the solar system, the life cycle of the Sun. In my first video, I mentioned that the Sun was currently in its main sequence stage. Today, we're going to explore what exactly that means and learn a little bit about the past and the future of the Sun. Like any star, the first stage of the Sun's life was a nebula. A nebula is a giant cloud of gas and dust consisting mainly of hydrogen and helium. Gravity pulls the gas and dust together, forming clumps. As these clumps get bigger and bigger, the gravity keeps on getting stronger and stronger and makes the gas start to spin. As the gas spins faster and faster, it gets hotter and hotter as the particles collide and bump into each other. The core of the nebula forms a hot, dense protostar. The temperature continues to increase as the protostar grows, as the nebula continues to collapse. When the temperature of the core is around 15 million degrees Celsius, nuclear fusion begins. This is a process where hydrogen is turned into helium. This process creates enough outward pressure to balance the force of gravity, and the star will stay like this for a long period of time, roughly millions, even billions of years. The Sun is currently in its main sequence stage and has been for around 4.5 billion years. Once all the hydrogen fuel is used up in the core of the star, the core contracts. The outer shell of the star, which is still mostly hydrogen, expands and starts to glow red. This is because the star gets cooler, and the colour of the star depends on its temperature. In about 5 billion years, the Sun will swell up into a red giant, at which point it will engulf the two closest planets to the Sun, Mercury and Venus. The Earth will also become inhospitable. The next stage depends on the size of the star, which was initially dependent on the size of the nebula and how much matter was available to the growing star. For a star the size of our Sun, it will eject its outer layers and the core will contract again, leaving behind a white dwarf star. This star will eventually cool and fade away. For a star much more massive than our Sun, it would explode in a spectacular supernova, leaving behind a neutron star. Or, if the star is sufficiently large, it will explode in a supernova and leave behind a black hole. Thank you for watching this video on the life cycle of the Sun.